Hello students of class 8, once again I'm Sudi here and you are all welcome to my video. So today in my video I will show you the solutions of the exercise 7.2. There we are going to find out the cube roots of the given numbers. So the number given here are the perfect cubes only, so we are going to find out the cube root of these cube numbers. Okay, so there are altogether 10 questions are there in this question number 1. So I am going to show you the solution of 4 or 5 of them, and remaining is yours. Now let us start the Roman number 1 here. See, Roman number 1 is 64. You know that what is that particular number whose square is 64, then we have to find out. And that number is called the square root, sorry, cube root. So we are going to find out the cube root of the 64 here. So for that, what we have to follow? We have to follow the method called prime factorization method. So we are going to find out the cube root by prime factorization method. So let us factorize this 64. If factorize 64, then what will we start? 2. Yes, 2, 3 is 6, 2, 2 is 4. Next, we have 2 again. 2, 1 is 2, and 2, 6 is 12. Next, we can still continue. 2, 8 is 16. Then we have here 2, 4, and we get here 2 and 2. So when we get the prime number, then we can stop the division here. So this is all the prime factors of this 64. So what we are going to find out is that therefore cube root must write 3 here. If it is not, then it is called square root, isn't it? So for cube root we have to write this number 3. Okay, cube root of 64. Cube root of 64, you can write like this, equal to the product of its prime factor, cube root over, yes, again I'll write down here, equal to cube root over 2 into 2 into 2 into 2 into 2 into 2. 2 6 2 6 are there, isn't it? 1 2 3 4 5 6. Then we have to root 3 of the number itself, isn't it? Then next we have like this, cube root over 2 to the power cube into 2 to the power cube, isn't it? Then this cube root and this cube and also with this cube all can be cancelled, and we are having here 2 into 2 is 4. So 4 is the answer. The cube root of the number given here 64 is 4. Okay. So likewise, let us find out the cube root of the given number here. So first of all, what we have to do, we have to factorize. We have to find out the prime factors of this number. Yeah. So 1, 0, 6, 4, 8. Then we start with 2 here, 2 5 is 10, 2 3 is 6, 2 2 is 4, and 2 4 is 8 here. Still we can continue with 2 here. Yes. 2. 2 2 is 4, 2 6 is 12, 2 6 is 12, 2 2 is 4. Still we can continue with 2 here. 2 1 is 2, 2 3 is 6, 2 3 is 6, 2 1 is 2. And now here we cannot continue with the 2, 3 also cannot be, 5 also cannot be, 7 also cannot be, 9 also cannot be. Now we check about the 11. Okay, 11. 11 1 is 11, isn't it? 11 2 is 22, 11 1 is 11. Then here we got again 11, 11 is 121. So the prime factors of this number are 2, 2, 2, and 11, 11, 11. 2 trees are there and 11 trees are there, isn't it? So therefore, cube root over cube root of 10648 is equal to cube root over. So write all this prime factor. Write down the prime factors of all this. You have factorized unit. So what are they? 2 into 2 into 2 into 11 into 11 into 11. So this is a. So we group this three, this unit, yes. Then we have here cube root over to the power 3 into 11 to the power 3 like this, isn't it? So this cube root and cubes can be cancelled. Then we get here 2 into 11, which is 22. So 22 is the cube root of the number given here is 10,648. Okay. Now let us go to the next question. Question number 7. Roman number 7 we have number 11,592. So we are going to find out the cube root of this number. So for that, first of all, we have to find the prime factors, isn't it? Yes. 1, 1, 0, 5, 9, 2. So here we start with 2 here. Yes. 2, 2 5s are 10, 2 5s are 10, unit place. 2 2s are 4, and yeah, 2 9s are 18, and 2 6s are 12. Then here again, we can still continue with 2, 2 2s are 4, and 2 7s are 14, 2 6 are 12, 2 4s are 8, 2 8 is 16. Still, we can continue with 2. 2 1 is 2, 2 3 is 6, 2 8 is 16, 2 2 is 4, 2 4 is 8 here. Next, we have again still with 2. 2 6 is 12. Yes. 2 9 is 18, 2 1 is 2, 2 2 is 4. Still, we can continue with 2. 2 3 is 6, 2 4 is 8, 2 5 is 10, 2 6 is 12 here. Then still again with 2 here, 2 1 is 2, 2 7 is 14, 2 2 is 4, 2 8 is 16. And still we can continue with 2, 2. 2 8 is 16, 2 6 is 12, 2 4 is 18. Now next, still we can continue with 2, 2 4 is 8, 2 3 is 6, 2 2 is 4. Now still we can continue with 2 here. 2. 2 2s are 4, 2 1 is 2, and 2 6 is 12 here. Still with 2. 2. 2 1 is 2, and 0 8. Isn't it? Yes. Then here we have again with 2. We can still divide with 2. So 2 5s are 10, and 2 4s are 8 here. Then here again still 2 2. 2 2s are 4, and 2 7s are 14. Now we cannot continue with the 2 now. We are going to continue with the other number 3. Okay? 3, prime number 3. Then 3 9s are 27, and we got here 3 3s are 9. So these are all prime numbers of the given number here, and from these prime factors we can find out the square. We can find out the cube root of the number here. So here, my dear students, you see here. Therefore, cube root over 110592. Cube root of 11,592 is cube root over 2, isn't it? 6, 1, 2, 3. 1 we can move, isn't it? Yes. Again, 1, 2, 3. 1, 2, 3. 1, 0. 1, 2, 3. Yeah. 1, 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 2 into 2 into 2 into 2. They are all cube, cube. This much of 2 are getting this number of 2's with grouping 3 of them. We are getting 1, 2, 3, 4 times. Grouping 3 times. Yeah, see, all the 2's are there, isn't it? Then at last we have into 3 cube. 3, 1, 2, 3, isn't it? Yes. So after that, my guess when you see here, we can cancel this cube root and all the cubes here. Okay. Then we got here 2 into 2 into 2 into 2 into 3. So here up to here you will have 8 into 2 into 3. So 8 cubes are 16. 16 into 3. How much you get here? 6 3s are 18, isn't it? 1 in hand, 48. So 48 is the cube root of the number given here. The answer is 48. Okay. So the answer is 48. The cube root of the given number here 11,592. The cube root is 48. If you multiply 48 3 times, then you will get this number here 11,592. So how many numbers? How many numbers are there? How many twos are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are there. So 3 we group, then 4 times of 2 will come here with the power 3 or as 2 cubes. 2 cubes, 4s are there. 2 cubes, 2 cubes, 2 cubes. Isn't it? Then one more number is there 3. So 3 only 3 are there. So 3 cubes we are getting. Isn't it? We pair only 3 times here. So 3 one time only. So here the cubes and the cube root can be cancelled among themselves, and we get here only 2 into 2 into 2 into 2 into 3, which is 48 now. So 48 is the cube root of the given number. So this is the answer of these questions, and let us see one more or two more of the questions. Okay. So my dear student, we have another question number Roman 10. So Roman 10, I will show you, okay, for this question, and the remaining, please, it is your to practice and do some of them as homework and show me also. Okay, clear? When you have time, when you are practicing, when you are doing, please show that as a homework also. Right. Now, let's go. Here the number is 91,125, so we have to factorize this first, isn't it? To get the prime numbers. Yes. 91125. Prime factorization. Yes. So my dear student, this number cannot be started with the smallest number 2. So next smaller number we can smaller prime number that there is 3, isn't it? Whether we can divide by 3 or not, you see 3, 10, 11, 12. 13, 14, 15, 16, 18. Yes, it can be. So start with the 3. 3 3s are 9, and okay, 3 3s are 9. Then we got 2, with 1, 2, 7, and 3, 5 we got here. Next, again 3. 3 1 is 3, 3 1 is 3, 3 2 is 6, 3 5 is 18 again. Then still we all can continue with 3. 3 3s are 9, and 3 7s are 21, 3 5s are 15 here again. Still we can continue with 3. 3 1 is 3, 3 2 is 6, 3 5 is 15, and still we can continue with the 3. Isn't it? Yeah. That's what we need. My guest in here, one more number is missing. This I'm coming back again. See, 3 3 is a 9. So whatever two numbers are there, two numbers we cannot bring down together. To bring down two numbers together here, we keep 1 0 here. Then we get here 3 3 is 9 here. Then 3 3 is 9. Then 2 7 is 21, and 3 5 is 50. We get here. Okay. So one more 0 has to put here. So there are two numbers. So two these are there. So to bring down this or to divide this together. Okay. Then next. Still 3. 3 1 is 3, and 3 0. Yes, 3 1 is 3 and 3 1 is 0. 0, 3 1 is 3, 3 2 is 6, 3 5 is 15. Again here, still 3, 3 3 is 9, 1, and again 3 3 is 9. Then we got here 3 7, 3 5 15. Yes. Then next we have, we can still continue with the 3 here. Yes, we can still continue with the 3. 3 1, 3 1, 3 2, 3 5. Then here 9, 10, 11. So 7, 8, 9. Yes. Still we can continue with 3. Yeah. 3, 3 is a 9, 2, 7, 5. Now still we can continue with 3, 3, 1, then 3, 1 here, okay. Then 17 is 3, 5 is 15, then 3 2 is 6, 3 5 is 15. Now 5, 6, 7, 8. Now we got here, with this number we cannot divide by the 3, so we will divide by 5. Next. That is, we cannot factorize the number here by 3, so we will take 5 here. 5 2s are 10. Then 5 5s are 25. Here, then here 5 5s are 25. So these are the numbers. If you want to still continue, then you can do one more like this. Okay. So these are the prime factors of the given number. So yes, you know what to do with the prime factors, as you have to group three of them and you have to multiply the numbers, isn't it? So let us, therefore, cube root of 91125, okay, yes, is equal to cube root over 1 2 3 4 5 6, means 3 into 3, 3 cube to 3 cube into 5 cube. This all. This 3 we group, this 3 we group, and this 3. So 3 cube into 3 cube into 5 cube. Then this cube and cubes can be cancelled, isn't it? Then we have here 3 into 5. So 3 3s are 9. 9 5s are 45. So 45 is the answer of this question. Means the cube root of 91,125 is 45. So 45 cube is this number. I mean the number given here. The cube of 45. Cube of 45 is 91,925, and cube root of 91,125 is 45. So what happened here, I would like to just remind you one more point, is that the finding of cube root is also inverse operation of finding the cube of the number. Finding the cube root is also inverse operation of finding the cube of the number. Like that, in the square also we have studied that the finding of square root is also the inverse operation of finding the squares, isn't it? Like this, we here also come across that the finding the cube root is the inverse operation of finding the cubes of the number. Okay, so with this we have finished the question number 1 here. Then let us go to the next question, question number 2. And my dear student, question number 2 is true or false only. So just think yourself, and if you have really difficulties there in finding the answer of the question number 2, please you can call me or you can ask me, okay, at any time. But question number 2 is true or false only, so please you try yourself question number 2. And now with this, let us go to next question number 3. Okay, the question number 3 is the last question of this chapter, so let us see. Yeah, hello students, once again we have question number 3 here. In question number 3, so we have to guess without factorization what is the cube root of the given number. I'm just made it short here, but it's a very long, extensive questions written there, so you can check in your book what is not that much of very important here, so I just write the themes of the question only. We have to guess we have to assume, we have to estimate the cube root of the given here, like we did in the square root, also estimating square root, isn't it? So here is estimating cube root only. So the number given here is a perfect cube, so we are going to estimate the cube root of the given number here. So for that, what we have to do, we have to group three numbers, start from the right side, extreme right side, isn't it? So let us see. So first of all, what we have to do, we are going to group three of them. So this here, we start from here. Okay. So we get here 3, 3, 1. So 3, 3, 1, you see in the last digit. In the last digit, there is 1. So what happened? Any number which is having 1 is the number in unit place. 1 is the unit place. Okay. So if we take the cubes of the number, how many times the 1 multiplied we get the 1 itself, isn't it? So there is nothing to change about the digits in the cube roots or in the cubes. Okay, both will be having the same digits. It means any number having 1 in the unit place, 1 is the last digit, so the cubes or the cube root also will have the same number of 1, isn't it? So so the last digit will take as 1. So last digit means digit in unit place. Digit in unit place is 1. That means let us take 1. Okay, clear. Then what happened about the digit in the 10th place of the square root? So for that, what happened? We get 1 here. Next, see, after striking this 3 from the right side, 3 digits from the right side, we have only 1 here. This 1 here, isn't it? 1 here. So what happened? 1, we know that 1 is the number that lies within the 1 cube. So we take this 1 number 1. So again, 1 is in 10 place. Hence, place now. That means the cube root of the given number is having 1 in the unit place, again 1 in the 10th place. Okay. Yes. See, actually we have to find out the remaining the remaining digits, or the remaining numbers making by the digits after we strike this tree. Only 1, isn't it? We have to find out that this number is lying in the cube of which number, but here it is 1, so there is no any number again to find out. So we will get the 1 itself, isn't it? So 1 will be the number in the 10th place again, because of only 1 will be made here, isn't it? Just like in this, after grouping this tree. Okay, so therefore cube root of 1, 3, 3, 1 equal to 11 is the answer. Understand? Unit place 1 because of this unit place is 1 also, isn't it? And because of only 1 is remaining here, so 1 will be number between the 1 cubes and the other cubes. But we have to take the smaller one. Smaller one is the 1 cube only, isn't it? So 1 cube. So this number 1 will take, and this number 1 will be the number in the 10th place. Is the number in the 10th place or in the digit in the 10th place. Okay, you can write like this, doesn't matter. Is the digit in 10th place. Okay. Digit in 10th place. That means 1 place 1. 10 place also 1. So 11. 11 is the cube root of the given number here. Like this, some more number are there, so we are going to find out. Okay, my dear student, I will like to tell some more points about the cube root here in estimating the cube root. That is, my dear student, see about striking of three numbers because of the cube. So first three number we have to count and we have to group it. Okay, and the next three. But next no three digits are there, only one, so we have to do one. That's all. But see, in other cases when there is no one, if it is other numbers, so what will be the last digit? What will be the digit in the place? I will just roughly tell you. Try to understand. Okay. 1 point I'm bringing about the square root. In the square root, we have studied about that 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 and 9. 1 and 9 has relations when we are counting the or when we are considering the last digit of the square, isn't it? Yes. That means these two number 1 and 9, if it is in the last digit of the square of the number, then the square number will having the digit as 1 only, isn't it? Yes, 1 only. So 1 or 9, isn't it? And then 2 or 8. They will have 4 in the unit place. The square of the number having 2 or 8 in the last digit, means in the unit place, then the square number will have 4 as the last digit, okay, or 4 in the unit place. But for this 3 and 7, they will have 9 in the last digit, isn't it? 3 3 is 9, 7 7 is 49. The last digit of the square is 9. And here 4 and 6, we have 6, isn't it? 5 will be 5. So what happened here, when we taking this point, okay, taking this point, so what happened if, now come back for the cube root, come back for the cube root, come back to the cube root. Now in estimation, the current question for this only. The other question that having there, so some other numbers are there. Some other numbers are there for estimating that only. I'm giving you this idea. Okay. See, my dear student, take this reference or refer these points, okay, of the square root. Means those numbers are there here, or those numbers is in the this natural number. Okay, 1 and 9, 2 and 8, 3 and 7, 4 and 6. For example, if a number is having yeah, if a number is 1, no doubt. Okay, 1 is okay. Then if 9 is okay. Then suppose if the number is having suppose in unit place, that's what we need. Let us say some numbers 5, 6, 2, 4, 2, for example. See the last digit. The last digit is having 2. So what happened? The last digit having 2 will estimate that this is a cube number. So the cube root of this cube number, the last digit will have 8. Why 8? 2 and 8. Okay. So unit digit in the unit. Yes. This. So let us take one example. 5, 6, 2, 4, 8. This is a cube number. Let us assume that it is cube number if you find that after striking 3 of this, then the last digit means the digit in the one place is 2, then the digit the digit in the one place of the square root will be 8. 2 and 8 like this. Means digit in unit place. 8 for the cube for the cube root for the cube root. Okay, click cube root. They will get two-digit number or three-digit number, isn't it? The last digit, or we can say that digit, one place will be 8 here. It is 2 here. Okay, it is 2 here, then it will be 8. And suppose, for example, I will take again 5, 6, 2, 4, 8, for example. Last digit is 8 now, another number. Then the digit in the unit place, digit in unit place, unit place will be just if 2, then 8. 8. Okay, if it is 8, then 2. Again, just I'm taking some more example. For example, 5, 6, 2, 4, 7. If you find that 7 is there in the last digit, and we strike this out. So we have to find out the last digit from here. So that digit is 7, and then digit in the unit place. Digit in the unit place will be 3. 3 and 7. Okay, 3 and 7. Got it? Yeah. It is 7, 3. Now then, let us think that 5, 6, 2, 4, 3. If it is, here we get 3, then digit in unit place is 3 and 7. Will be 7. Okay, unit place will be 7. And the other number in the 10th place we have to find out from 56. Isn't it? That I will show it here in the next. One more I will do, okay? Then we will find. So this is what I want to make you to understand. So in the unit place it is 2, then 8. It is 8, then 2. It is 7, then 3. It is 3, then 7. And here if it is 4, then 6, or 6, then 4. Okay. Now one more number we'll try to estimate. Number is here. You got the number here. Yeah, 4913. So we are doing this. Then here in 413 we have this 3 as the last digit, isn't it? Yes, 3 is the last digit we have. Yes. So what will be the first we have to find out the digit in one place of the cube root, isn't it? So from here there is digit in unit place. Digit in unit place. What will be the number? Is what? See 3. So let us assume one more thing also. Okay. 3 to 3 will be 7. I told you. But let us think that cube of this 3. That is how much? 3 into 3, then 3 3 is 9, then 9 3 is 27. Will be this 7. Yes. I told you that it is 3 then 7. Yes or no? Yes. Then next we have 4 here. So this 4 is we get here only one digit, there is 4. So 4 there is okay. Then it goes to the 4. So you see that 4 is 4 is in between the 1 cube and 2 cube. Yes, 1 cube and 1 cube is less than the number 4, but it is less than 2 cube. So the number lies between this number 4. Not पहले में तो 1 था इसलिए just we take 1, but here this not 1, 4, isn't it? We have to find out this number is lying in between which whose cubes. Now we get here the number 4 is lying between the cube of 1 and cube of 2, isn't it? Yes. Cube of 1 is, you see here, it is q1, and then it is cube of 2 is, you know, it is, isn't it? The number is lying between 1 and 2. Yes, correct. Then what we have to do, we have to take the smaller one. So whose cube is this? This cube of 1. Then we will take this, the digit 1 to be in the 10th place. That is, 1 is the digit, or 1 will be the digit in 10th place. 10th place. Okay. Then what is the cube root of the given number? The cube root of the given number 4913 is equal to 1. 10 place, unit place 7. 17 is the answer. Like this we can. One more I will do. Okay. Let's see. Note down this. So here my dear student, one more number is there in number 3. I'm taking this number, and other who is not done, you can just check yourself. Okay. So I have a number that the number is a perfect cube, and we are going to estimate the cube root of this perfect cube. Okay, perfect cube. So here we are going to group this 3 and this 2, because only 2. After grouping this 3, then only 2 remain. 2 that 2 digit will be going off. So, okay. Then from here we get 7, 6, 8. In 7, 6, 8 we have the 8 as the last digit. So what will be the digit? That is the digit in unit place. What will be the in unit place? Let us see. Is what will be unit place? 8. What will unit place will be this 8? It must be 2, isn't it? So let us find out whether it is true or not. So just take the cube of 8. 8 into 8. Ye 8 का cube ले लो, isn't it? And 8 8 just 64, isn't it? 8 8 just 64. Again multiply with 8. How much? 8 4 just 32. 3 in hand. 6 8 just 6 8 just 48, 49, 50, 51. Now see the last digit. When you take the cube of 8, you got the last digit 2. That's why if it is 8, you get the last digit as, I mean the digit in the 1 will be 2. You know, just 2. Yes. Then other number we get here 32. So we have to find out whether this 32 between which number the 32 lies. Means between which cube number the 32 is found. So my dear student, you see here 2 cube is 8 and 3 cube, yeah, 3 cube is, now we got 3 cubes as the yeah, 3 cubes, okay, and the 4 cube, 3 cube and 4 cube. 3 cube, you see 3 cube is that is 3 cube, how much? 3 cube is 27, isn't it? And 32 lies between 3 cube and 4 cube. 4 cube, how much? 4 4, the 16, 64 is a 16 4, how much? 6 4 is 24, 2 in hand, 64. You got it 64. So the number 32 is between the cube of 3 and the cube of 4 here, and we'll take the smaller one here. Okay, we take the smaller one, 27, not the bigger one, 27. So 27, which cube is this? This is the cube of 3. So we take this number 3 to be the number in the, to be the digit in the 10th place. So 3 is the digit in 10th place. 10th place now. Okay, that is, therefore, cube root of 3, 2, 7, 6, 8 is equal to, how much does guess yourself? So what will be the cube root now? Yes, 10 digits 3 and 1 digit 2. So 32 is the cube root of 32,768. Like this we estimate. Okay, yeah. So for this, please you try to go through again and again this part and try to understand how to estimate the cube root of a cube number, and then also compare those relations of the digits. When the digit is 8, 2, when the digit is 3, 7, when 7 is there, 3, when the digit is when the last digit is 2, 8, and if it is 8 then it is 2, if it is 3 then 7, and 7 then it is 3, like this, vice versa. Means of this numbers. Okay, don't forget. Okay, clear. So my dear student, here we come the last part of the chapters. With this we finish our chapter number 7. And in chapter number 7, let us try to remember what we have studied. We have studied about the cubes of a number and the cube roots. So once again, finding the cube root is the inverse operation of finding the cubes of a number, and there we use the method for finding the cube root is prime factorization. Okay, so that's all for today's sessions, and we'll meet again in the next session. Okay, till then, have a nice day all of you, and thank you once again for watching my video. Bye bye.